Welcome to Week 7 of IML 625, where we will focus on content organization and information access. This topic is fundamental to the design, development, and evaluation of digital libraries. As final year students, you are expected not only to understand what content organization is, but also why it matters and how it affects user access, system performance, and information retrieval effectiveness. In this lecture, we will first examine content organization schemes used in digital libraries, and then explore how user behavior and interaction influence information access. These two components are closely connected and must be designed together to create effective digital library systems. Content organization refers to how digital materials, such as text documents, images, videos, and datasets, are categorized, indexed, and structured within a digital library or information retrieval system. In a digital environment, information does not organize itself. Without deliberate design, digital collections become fragmented, inconsistent, and difficult to search. The primary goal of content organization is to ensure that information is easily discoverable and accessible. This means users should be able to locate relevant content efficiently, whether they are browsing broadly or conducting precise searches. For digital libraries, effective content organization is not optional. It is a core requirement for usability, retrieval accuracy, and long-term sustainability. In this slide, we look at the three core features of content organization: categorization, indexing, and structure. These three elements work together in almost every digital library system. First, categorization. Categorization means grouping similar resources into meaningful categories or subject areas. For example, in an academic digital library, theses may be categorized under disciplines such as computer science, information science, or business studies. Within a digital repository, research outputs might also be categorized as journal articles, conference papers, or datasets. This helps users immediately understand what type of material they are accessing. Second, indexing. Indexing involves describing each item using specific attributes such as title, author, keywords, publication date, and abstract. In a library ecosystem, this is done through metadata. For instance, when a student searches for digital preservation, the system does not search the document randomly. Instead, it retrieves items based on indexed metadata fields like subject terms, abstracts, or keywords assigned by librarians or systems. Without indexing, accurate searching would not be possible. Third, structure. Structure refers to how content is organized logically within the system, often using hierarchical arrangements, taxonomies, or controlled vocabularies. A common library example is subject-based navigation, where users browse from a broad category like information science, then move to digital libraries, and finally to content organization. This hierarchical structure supports both browsing and learning, especially for users who are exploring a topic rather than searching for a specific title. Together, categorization, indexing, and structure form the backbone of digital library ecosystems, ensuring that information is organized, searchable, and meaningful to users. This slide explains why effective content organization is critically important in digital libraries. The impact of content organization can be seen directly in how users search, retrieve, and use information. First, improving discoverability and access. When content is well organized, users can find information more easily. For example, in an institutional repository, a postgraduate student searching for research on open data will be able to retrieve relevant theses, articles, and datasets if the content is properly categorized and indexed. Without clear organization, important research outputs may remain hidden, even though they exist in the system. Second, facilitating efficient information retrieval. Effective indexing allows the system to retrieve results quickly and accurately. In a digital library database, metadata such as subject terms and abstracts enable the system to filter out irrelevant materials. This improves precision and recall, which are key measures of information retrieval effectiveness. For researchers, this means less time spent screening irrelevant results. Third, enhancing user experience. Logical organization supports smooth navigation. For example, faceted search in academic databases allows users to refine results by year, author, or document type. This reduces frustration and makes the system more user-friendly, especially for students conducting literature reviews. Fourth, supporting data integrity and quality control. In library systems, consistent metadata ensures that records remain accurate and up to date. For example, standardized author names and subject terms prevent duplication and confusion in catalogs and repositories. This is essential for maintaining reliable digital collections. Fifth, scalability. As digital libraries grow, effective content organization ensures that new materials can be added without disrupting the system. For example, national digital libraries that continuously ingest new publications rely on structured metadata and classification systems to remain manageable over time. Finally, supporting different types of users. Different users interact with digital libraries in different ways. Researchers may rely on advanced search filters, while undergraduate students may prefer browsing by subject. Effective content organization accommodates these diverse needs and ensures equitable access to information. In summary, effective content organization is not just a technical issue, it directly shapes the usability, credibility, and long-term success of digital library systems. Let us look at a concrete example to better understand how content organization works in a digital library environment. Imagine a digital library that contains thousands of books, journal articles, and multimedia resources. Without a proper organization system, users would struggle to locate the information they need. First, categorization. In this digital library, books may be organized by broad subject areas such as science, history, and literature. At the same time, journal articles may be categorized by research themes, for example climate change or artificial intelligence research. This allows users to quickly narrow down content based on subject or topic before performing detailed searches. Second, indexing. Every item in the digital library is described using metadata. This includes information such as the title, author, publication date, abstract, keywords, and language. When a user searches for a term like quantum computing, the system does not scan documents randomly. Instead, it retrieves relevant items by matching the search query with the indexed metadata fields. This is what enables fast and accurate search results. Third, structure. The digital library also supports browsing through a hierarchical structure. For example, a user may start at a main category such as science, then move into the subcategory physics, and finally explore a more specific area like quantum mechanics. This hierarchical structure is especially useful for users who are exploring a topic or learning a subject area, rather than searching for a specific document. Together, categorization, indexing, and structure work as an integrated system to ensure that digital library content is organized, searchable, and meaningful to users. In this slide, we introduce the concept of content organization schemes. Content organization schemes refer to the methods or structural frameworks used to organize, categorize, and represent content within a digital library or information system. These schemes provide the foundation that allows digital libraries to manage large and complex collections in a systematic way. In a digital library environment, content does not exist in isolation. Books, journal articles, theses, multimedia files, and datasets must all be organized using clear and consistent schemes so that users can locate and access them efficiently. These schemes play a crucial role in ensuring that content is discoverable, meaning users can find relevant resources, searchable, meaning systems can retrieve accurate results, and accessible, meaning information can be used by different types of users. For example, without standardized organization schemes, a search for a topic such as digital preservation might return incomplete or inconsistent results across different collections. Content organization schemes ensure that similar resources are represented in a consistent way, regardless of format or source. In the following slides, we will examine several key types of content organization schemes commonly used in digital libraries, including metadata standards, taxonomies, controlled vocabularies, folksonomies, and ontologies. Each of these plays a distinct role in supporting effective information access. In this slide, we focus on the first and most fundamental content organization scheme, which is metadata standards. Metadata refers to structured information that describes digital content in a digital library. It provides essential details such as who created the content, when it was created or published, and what the content is about. Without metadata, digital resources would be difficult to identify, manage, and retrieve. In a digital library system, metadata is primarily used to index and retrieve content. When users perform a search, the system relies on metadata fields, such as title, author, subject, and keywords, to match user queries with relevant resources. This means that metadata plays a direct role in search accuracy and retrieval performance. Metadata standards are formalized sets of rules and guidelines that define which metadata elements should be included, how they should be structured, and what each element represents. These standards ensure that metadata is created in a consistent and meaningful way across different collections and systems. The main goal of using metadata standards is to ensure consistency, accuracy, and interoperability. Consistency ensures that similar resources are described in the same way. Accuracy ensures that metadata correctly represents the content. Interoperability allows metadata to be shared and understood across different digital library systems, repositories, and platforms. For digital libraries operating at institutional, national, or international levels, metadata standards are essential for enabling resource sharing, system integration, and long-term preservation. In this slide, we look at 3 common metadata standards that are widely used in digital library and library ecosystems: Dublin Core, MARC, and MODS. Each standard serves a different purpose and level of complexity. First, Dublin Core. Dublin Core is a simple and widely used metadata standard designed to describe a broad range of digital content. This includes documents, images, videos, websites, and learning materials. It consists of a small set of core elements such as title, creator, subject, date, format, and language. In a digital library context, Dublin Core is often used in institutional repositories and digital collections because it is easy to implement and flexible. For example, when uploading a thesis or research article into a university repository, Dublin Core metadata allows the item to be quickly described and made searchable across systems. Second, MARC, or machine-readable cataloging. MARC is a more complex metadata standard used primarily by libraries for cataloging books, journals, and other physical library materials. It uses highly structured fields and subfields to store detailed bibliographic information. In traditional and integrated library systems, MARC records form the backbone of online public access catalogs. For example, when a user searches a library catalog for a printed book, the information displayed, such as author, title, edition, and publication details, is retrieved from a MARC record. Third, MODS, or Metadata Object Description Schema. MODS offers a middle ground between Dublin Core and MARC. It is more detailed and structured than Dublin Core, but less complex than MARC. MODS is often used for describing digital and archival objects that require richer metadata without the full complexity of MARC. For example, in a digital archive or special collections repository, MODS may be used to describe digitized manuscripts, photographs, or historical documents, where more descriptive detail is needed to support research and preservation. In summary, Dublin Core prioritizes simplicity, MARC prioritizes detailed bibliographic control, and MODS provides a flexible balance between the two. Choosing the appropriate metadata standard depends on the type of content, system requirements, and user needs. In this slide, we focus on taxonomies and classification systems, which are hierarchical methods used to organize content based on relationships between terms and subjects. A taxonomy structures information from broad categories to more specific subcategories. This hierarchical arrangement helps users understand how knowledge is organized and how different subjects are related to one another. In digital libraries, taxonomies are commonly used to group large collections of content into manageable structures. For example, instead of presenting thousands of documents in a single list, the system allows users to browse by subject areas and gradually narrow their focus. Taxonomies are particularly useful when managing large volumes of data, such as national digital libraries, academic repositories, or multidisciplinary research databases. They support intuitive navigation, especially for users who are exploring a topic rather than searching for a specific title. Two well-known examples of classification systems used in libraries are the Library of Congress Classification, or LCC, and the Dewey Decimal Classification, or DDC. In LCC, knowledge is divided into broad subject classes, such as philosophy, science, and social sciences, which are then further subdivided into more specific topics. This system is commonly used in academic and research libraries. In contrast, DDC organizes knowledge into 10 main classes, each further divided into more detailed sections. DDC is widely used in public and school libraries due to its simplicity and ease of use. In digital library systems, these classification structures are often adapted to support subject browsing, filtering, and hierarchical navigation, making complex collections easier to explore and understand. In this slide, we examine controlled vocabularies, which are standardized sets of terms used consistently within a particular domain or collection. In digital libraries, controlled vocabularies play a critical role in ensuring that content is categorized and described using a fixed and agreed-upon set of terms. This reduces ambiguity and improves search accuracy, especially in large and diverse collections. Without controlled vocabularies, similar concepts may be described using different terms. For example, one record may use the term information management, while another uses data management to describe similar content. Controlled vocabularies ensure that the same preferred term is applied consistently, allowing the system to retrieve all relevant items during a search. One common example of controlled vocabularies is a thesaurus. A thesaurus does not simply list terms, it also shows relationships between them. These relationships include synonyms, broader terms, narrower terms, and related terms. In a digital library context, this means that when a user searches for a term, the system can also guide them to related or more specific concepts. For instance, a search for renewable energy may be linked to narrower terms such as solar energy or wind energy, helping users refine or expand their search. Another important example is subject headings. Subject headings are standardized terms used to describe the subject content of a resource, and they are commonly applied in library cataloging. A well-known example is the Library of Congress Subject Headings, or LCSH. When cataloging a book or digital resource, librarians assign official subject headings rather than free text keywords. This ensures consistency across catalog records and allows users to retrieve all materials related to a subject, even if different authors use different terminology. Overall, controlled vocabularies improve precision, consistency, and interoperability in digital library systems, making them essential for effective information retrieval and scholarly discovery. In this slide, we examine folksonomies, which are classification systems created by users through the tagging or labeling of content. Unlike formal taxonomies or controlled vocabularies, folksonomies are not designed by librarians or system administrators. Instead, they emerge from the collective input of users, who assign tags based on their personal understanding, experience, or language preferences. In a digital library or digital repository, this means that users may tag resources using terms that feel natural to them. For example, a research article on climate policy may be tagged by users with labels such as climate action, environment, or sustainability, even if these terms are not part of an official subject heading list. These user-generated tags reflect how users think about content, rather than forcing content to fit into a predefined structure. As a result, folksonomies can capture emerging terms, trending topics, or informal language that formal classification systems may not yet include. There are three key characteristics of folksonomies. First, they are user-driven. The classification grows organically as users continue to tag content. Second, they are flexible. New tags can be added at any time without revising an entire classification scheme. Third, they are less formal. There is no strict hierarchy or controlled terminology, which allows creativity but may also introduce inconsistency. In digital library ecosystems, folksonomies are often used alongside formal systems such as controlled vocabularies. This hybrid approach combines professional structure with user perspectives, enhancing discoverability while maintaining overall system coherence. In this slide, we examine ontologies, which represent the most advanced form of content organization in digital libraries and information systems. An ontology is a formal and structured representation of knowledge within a specific domain. It does not only list terms or categories, but explicitly defines the relationships between concepts and the attributes that describe them. Unlike basic classification systems or tagging approaches, ontologies capture meaning. For example, an ontology can represent statements such as a cat is a type of animal, a dog is a type of animal, and an animal has legs. These relationships allow systems to understand how concepts are connected, not just how they are labeled. In a digital library context, this means that the system can infer relationships between resources. For instance, if a user searches for animals, the system can automatically retrieve resources related to cats, dogs, and other subclasses, even if the exact search term does not appear in the metadata. Ontologies have three key characteristics. First, they are formal and detailed. Ontologies are created using well-defined models and rules, often designed for machine processing. Second, they capture semantic meaning. This allows systems to understand concepts at a deeper level, supporting intelligent search and knowledge discovery. Third, they model complex relationships, including hierarchical, associative, and part-whole relationships. In modern digital library ecosystems, ontologies are commonly used in semantic digital libraries, linked data environments, and artificial intelligence applications. They enable more precise retrieval, automated reasoning, and advanced knowledge integration across systems. Understanding ontologies prepares you for working with next-generation digital libraries that move beyond traditional cataloging toward intelligent and interconnected information systems. In this section, we focus on user behavior and interaction in digital library systems. User behavior and interaction refer to the ways users engage with digital libraries in order to find, access, and use information. This includes how users search, browse, filter results, read content, and make decisions about which resources are relevant to their needs. Understanding user behavior is critical because a digital library is only effective if users can interact with it successfully. Even the most well-organized collection will fail if users find the system confusing, inefficient, or difficult to navigate. In digital library design, studying user behavior helps us understand questions such as, how do users search for information? Do they prefer browsing by subject or searching with keywords? What difficulties do they face when interacting with digital interfaces? By answering these questions, system designers and information professionals can develop digital libraries that are intuitive, efficient, and capable of delivering the right information to the right users at the right time. This area of study involves several key components. These include user-centered design, which focuses on designing systems around user needs, search and retrieval behavior, which examines how users formulate queries and interpret search results, user interaction with content, which looks at how users browse or explore information, and usability considerations, which ensure that systems are accessible, easy to use, and responsive. For digital libraries serving academic communities, understanding user behavior is especially important because users vary widely, from undergraduate students and postgraduate researchers to academics and professionals, each with different goals, skills, and expectations. In the following slides, we will explore each of these components in more detail to understand how user behavior shapes effective digital library systems. In this slide, we focus on user-centered design, commonly known as UCD. User-centered design is both a design philosophy and a systematic process that prioritizes the needs, preferences, and behaviors of users throughout the entire development of a system. Rather than designing systems based solely on technology or organizational assumptions, UCD places users at the core of all design decisions. In the context of digital libraries, UCD is especially important because users interact with systems in different ways and for different purposes. Some users may want quick access to specific articles, while others may prefer to browse collections or explore new topics. UCD aims to design digital library interfaces that are intuitive and easy to navigate. This includes clear layouts, understandable labels, and logical navigation structures that reduce user confusion. It also focuses on designing effective search mechanisms. For example, search interfaces should support both simple keyword searches for novice users and advanced search options for experienced researchers. In addition, UCD influences how content organization schemes are designed. Categories, metadata, and browsing structures should reflect how users think about information, not just how systems store it. By applying user-centered design, digital libraries can become more accessible, efficient, and responsive to user needs. Ultimately, UCD ensures that digital library systems support users in achieving their information goals with minimal effort and maximum satisfaction. As final-year students, understanding UCD prepares you to design, evaluate, and improve digital library systems that are not only technically sound but also genuinely usable and user-friendly. In this slide, we look at the 4 key elements of user-centered design, using examples from public library digital services. Public libraries serve a very diverse user population, making UCD especially important in this context. First, understanding user needs. In a public library, users include school students, senior citizens, job seekers, parents, and lifelong learners. Each group uses digital library systems differently. For example, a job seeker may want quick access to online newspapers, career resources, or government information, while senior citizens may face challenges such as small text sizes or unfamiliar interfaces. Understanding these needs helps public libraries design systems that are inclusive and easy to use for all segments of society. Second, user profiles and personas. Public libraries often develop personas such as secondary school students, working adults, retirees, or parents with young children. These personas help librarians and system designers anticipate how different users search for information. For instance, students may browse by subject for homework help, while adults may search directly for specific titles or services. Personas ensure that digital library systems do not cater only to one type of user. Third, user involvement. User-centered design requires direct user involvement. In public libraries, this may include user surveys, feedback forms on library websites, or usability testing of digital catalogs and ebook platforms. Feedback from users might reveal issues such as confusing menu labels, difficulty accessing ebooks, or unclear search results. By involving users, public libraries can identify real problems faced by the community and address them effectively. Fourth, iterative design. Iterative design means continuously improving digital library systems based on user feedback. Public libraries often update their online catalogs, mobile apps, or digital collections in response to changing user needs. For example, during periods of increased online usage, such as school holidays or emergencies, public libraries may redesign interfaces to highlight popular digital services. This continuous refinement ensures that public library digital systems remain relevant and user-friendly over time. Overall, applying user-centered design in public libraries ensures that digital library services are accessible, inclusive, and responsive to the needs of the wider community. In this slide, we focus on search and retrieval behavior, which refers to how users find and access information in a digital library system. In the context of public libraries, search and retrieval behavior is especially important because users come from very diverse backgrounds. They may include school students, parents, senior citizens, job seekers, and members of the general public, each with different levels of digital literacy and information needs. Understanding how these users search for information helps libraries improve search functions and ensure that content is accessible to everyone. A well-designed search system reduces frustration and allows users to find relevant information quickly and efficiently. To evaluate how effective a search system is, we often use three key concepts from information retrieval: precision, recall, and relevance. Precision refers to how many retrieved results are actually relevant. Recall refers to how many relevant items in the system are successfully retrieved. Relevance refers to how well the results match the user's information need. Let us now look at two common types of search behavior. First, keyword-based searching. In public library digital catalogs, users often type simple keywords into a search box. For example, a parent may type children's storybooks, or a job seeker may type resume writing. The system then matches these keywords against metadata fields such as title, subject, or keywords, or against the full text of documents. However, keyword-based searching has limitations. If users do not use the exact terms stored in the system, they may not retrieve the desired results. For instance, a user searching for elder care may miss relevant resources indexed under senior citizen services. Second, semantic search. Semantic search goes beyond matching exact keywords and attempts to understand the meaning behind the user's query. It recognizes synonyms and related terms to improve accuracy. In a public library system, this means that a search for heart attack may also retrieve resources indexed under myocardial infarction, even if the user does not know the medical term. Similarly, a search for job loss may retrieve materials related to unemployment assistance. By supporting semantic search, public libraries can better serve users who may not be familiar with formal or technical terminology. This improves inclusivity, relevance, and overall user satisfaction. In summary, understanding search and retrieval behavior allows public libraries to design search systems that are more accurate, user-friendly, and responsive to the real information needs of the community. User interaction refers to how users engage with the content they find in digital library systems. In public libraries, interaction patterns vary widely because users differ in age, background, and information needs. Some users prefer to explore content gradually, while others aim to locate specific information as quickly as possible. Digital library systems must therefore support multiple forms of interaction to accommodate these differences. Browsing is an exploratory approach to interaction. It is commonly used when users are unsure of what they are looking for and want to discover available resources. In a public library digital environment, a user may browse by subject categories such as health, education, or children's resources. From there, the user may narrow the focus by exploring subcategories or related collections, such as moving from health to healthy living or mental well-being. Browsing is particularly useful for casual users, parents selecting reading materials for children, or senior citizens exploring lifelong learning resources. Searching, in contrast, is a more targeted interaction method. It is used when users have a clear information need or specific criteria in mind. For example, a user accessing a public library digital catalog may search for a specific phrase such as climate change policies in Europe or financial assistance programs. In this case, the user expects precise and relevant results based on the entered query. Searching is often preferred by users who are time-sensitive, such as students completing assignments or adults seeking specific information. Effective digital library systems support both browsing and searching and allow users to move easily between these interaction modes. Understanding these interaction patterns enables public libraries to design digital services that are flexible, inclusive, and responsive to community needs. Personalization in digital libraries involves adapting content recommendations, search results, or system interfaces based on users' past interactions, preferences, and behaviors. This approach allows digital library systems to respond more effectively to individual information needs. One way personalization is implemented is through adapting to user behavior. By analyzing previous searches and interaction patterns, a digital library system can tailor the information presented to users. For example, if a user frequently searches for articles related to machine learning, the system may highlight related articles or suggest new content within the same domain. This helps users access relevant materials more efficiently without repeating similar searches. Personalization also includes the use of context-aware systems. Context-aware personalization adapts the system interface or search results based on the user's context, such as location, previous searches, or the time of access. For example, a digital library may display different search results or interface options depending on whether the user is identified as a student, a researcher, or a casual reader. Each user group is presented with content and tools that are more closely aligned with their typical information needs. Through adapting to user behavior and context, personalization enhances information access and improves the overall effectiveness of digital library services. Usability considerations focus on ensuring that digital library systems are easy to use, efficient, and accessible for all users. In public library digital environments, usability is especially important because users vary widely in age, digital skills, and information needs. One key usability aspect is interface design. A well-designed interface should be clear, intuitive, and visually simple. In a public library digital catalog, this means using readable text, clear icons, and logically arranged menus so that users can understand how to use the system without extensive guidance. Navigation is another critical consideration. Effective navigation allows users to move easily between different sections of a digital library. For example, clear menus, category labels, and breadcrumb trails help users understand where they are in the system and how to return to previous pages. Good navigation reduces confusion and supports both browsing and searching activities. Accessibility ensures that digital library systems can be used by all members of the community, including users with disabilities. In public libraries, accessibility may include features such as screen reader compatibility, keyboard navigation, adjustable text size, and sufficient color contrast. These features support inclusive access to digital information. Feedback mechanisms also play an important role in usability. Feedback helps users understand how the system is responding to their actions. One example is query suggestion, where the system offers suggested search terms as users type. This assists users who may be unsure of the correct keywords to use. Another example is result ranking. Search results should be ordered so that the most relevant items appear first. Effective ranking saves users time and helps them locate useful information quickly. Interactive elements, such as autocomplete, clickable filters, or highlighted search terms, further enhance usability by guiding users and making interactions more efficient. Overall, strong usability design ensures that public library digital systems are not only functional, but also inclusive, user-friendly, and capable of supporting meaningful access to information for diverse user groups. This slide highlights several key challenges faced in content organization and information access within digital library systems. These challenges affect system performance, usability, and long-term sustainability. The first challenge is scalability. As digital libraries continue to grow, the volume of digital content increases rapidly. Managing large and continuously expanding collections requires organization schemes and systems that can scale without losing efficiency. Without scalable structures, search performance may decline and content may become difficult to manage or retrieve. The second challenge is data integrity and consistency. Digital libraries rely heavily on metadata and structured information. Inconsistent metadata practices, duplicate records, or outdated information can reduce search accuracy and user trust. Maintaining data quality over time is especially challenging when content is contributed by multiple sources or systems. Another significant challenge involves cultural and linguistic differences. Digital libraries often serve users from diverse cultural backgrounds and language groups. Designing content organization systems that work effectively across different languages, terminologies, and cultural contexts is complex. Classification terms or subject labels that are meaningful in one context may not be easily understood in another. The final challenge relates to emerging trends. Rapid developments in technologies such as artificial intelligence, machine learning, and semantic web applications are changing how information is organized and accessed. Digital libraries must continuously adapt to these trends while ensuring that new technologies are implemented responsibly and effectively. Addressing these challenges is essential for developing digital library systems that remain reliable, inclusive, and capable of supporting effective information access in the long term. This lecture has discussed how content is organized and accessed in digital library systems. Content organization is important because it affects how easily users can find and use information. Different organization approaches, such as metadata standards, taxonomies, controlled vocabularies, folksonomies, and ontologies, help structure digital content and support effective searching and browsing. The lecture has also shown that understanding user behavior is essential. User-centered design, search behavior, personalization, and usability help ensure that digital library systems are easy to use and meet user needs. Digital libraries also face challenges, including managing large amounts of data, maintaining data quality, supporting different languages and cultures, and adapting to new technologies. Overall, effective digital libraries combine well-organized content with user-focused system design to provide meaningful and accessible information services. This concludes the lecture on content organization and information access.